Recording in
Hello
progress.
everyone. Welcome to Mathematics with Shahab Yaku. So now just few hours before your S1 exam, I just had a feeling to share some of my favorite questions which you can see on the screen right now. So let's get started. Maybe they will be really helpful for your upcoming exam in few hours. The first question is about normal distribution. The mean is given, the percentage is given, and an inequality is given. Apples have a weight greater than 87 grams. It's about weights of apple. Always make sure to write down the distribution. What is the question all about? It's about normal distribution. Then write down the inequality. What's the inequality? Probability x greater than 87 is 22%. When we do back solving, what do we mean by back solving? Using the probability to find the z value. We want to be sure that this probability is at least 0.5. Why? Because that's the limitation of the normal distribution table. We flip the inequality. We subtract the probability from 1. We look for the z value corresponding to this probability. But wait a minute. First, write down the steps. Probability z, convert z to x to z. 87 minus mu divided by sigma is 78%. The 78% z value is 0.782. Some people determine the sign by help of a diagram. Others determine with the idea that make sure the probability is at least 50%, lesser sign positive, greater sign negative. So it's positive. Just equate to find the value of sigma. This is the 4SF value. This is the 3SF value. A lot of people, they ask this question over and over again. What is the level of accuracy? The final level of accuracy is 3SF. The probabilities that the normal distribution table will give you, that is 4 decimal place. So work in 4 decimal places. Final answer 3SF. What's the big deal? The next part, very important. Find the probability that the weight of a randomly chosen apple of this variety differs from the mean weight by less than 4 grams. So 82, 4 grams on this side is 86, 4 grams on this side is 78. It differs by less than 4 grams. The difference could be in this direction, it could be in this direction, but it's lesser than 4 grams. So these are the two boundaries. Just work out the probability between the two, standardize, apply the relevant rule, and write down the probability. Final answer, 3SF. So now this thing is done for sure, that the final answer, unless otherwise stated, is 3SF. And yes, the z value that you use, that has a limitation of 3 decimal places. So we cannot help it. The probability that we get, that is 4 decimal places. Let it come out to be. Final answer should be 3SF. Now let me go to the next question and let me go to the favorites. Now these questions are selected at random. So maybe you will come across a normal and then a probability and then another normal and binomial and so on. Now, I like these questions, the jellies and the chocolates. And sometimes the flavor changes. It could be some other type of milk chocolate and dark chocolate and some other chocolate, white chocolate. And the bottom line of the story is, on and off, this question hasn't come for a long time. So you know what I mean. A company produces small boxes of sweets containing 5 jellies and 3 chocolates. Jamil chooses 3 sweets at random from the box. Draw a probability distribution table for the number of jellies that Jamil chooses. X is the number of jellies chosen. 5 for this thing, jellies. So this is not Jamil. Jamil is selecting J for jellies, and 3 for chocolates. And then it could be 0 and 3, 1 and 2, 2 and 1, 3 and 0. So what I've done, I have written down the number of ways. So that's 1 and then 56 and then 30 and then 10. Double check with this 8C3 without any restriction is 56. Now, if I'm looking for the probability, let me grab my red marker. So probability x is equals to 0 is 1 out of the total. Probability x is equals to 2. 2 is the number of jellies that is chosen. The question is with the perspective of jellies. That is 15 over 56. Probability x is equals to 3, actually 2. And I think this is 1. That comes out to be 30 over 56. And probability x is equals to 3. That is 10 over 56. Do not reduce the fractions. And then the question continues. The company also produces large boxes of sweets. For any large box, the probability it contains more jellies than chocolate is 0.64. So this is the condition. This is the perspective, the probability of success. 10 large boxes are chosen at random. Find the probability no more than. That means at most 7. That means 7 is inclusive. Of these boxes contains more jellies than chocolate. This is the probability of success. This is the number of trials. Binomial, remember, if they ask you for the condition, there is fixed number of trials and there are only 2 probabilities, that is, and those probabilities are constant, success and failure. And this is lesser than or equal to 7, 7, 6, 5, 4, 3, 2, 1, 0, too much. Therefore, 1 minus probability x is greater than or equal to 8. We find this probability, show this working, then use a calculator, write down this answer. So this thing is also done. So let me go back over here. Let me remove the questions that are done so that the numbers keep on decreasing. And I'm just making this video a little bit short so that you can use your time wisely. By the way, just by looking at this video, there isn't much to study any further. That will simply create anxiety. So now coming back to this. In a certain town, the time x hours for which people watch television in a week has a normal distribution with mean this and standard deviation this. Find the probability that a randomly chosen person from this town watches TV for less than 21 hours. Just the basic working, nothing special. Just look at the steps. That is what I want to focus on. The distribution, the original inequality, the standardization, the standardized value, correct to 3 dp, because that is the limitation of the normal distribution table. Then we go to 1.2, 1.23, write down this value. A lot of people having a difficulty with this. So I have written it over here, 8907 without the decimal. And then the third dp, that is 8. So add column 8, 15, simply add, and then write a decimal place over here. That's how I have taught in my classes. Final answer, 3SF. The next one, back solving. Find the value of k such that probability x less than k is 0.75. So x follows a normal distribution. Probability x less than k is 0.75. You have the strip at the bottom of the page. 75% value is giving you a z value of 0.674. These are the famous values for which you don't have to look in the table. 75, 90, 95, 97.5, 99, and 99.5. And these are the famous 6 values. These are used very rarely. So probability z lesser than this value, probability greater than 50%, lesser sign positive. This is the second question that we are doing. Take this thing, equate. Never ever equate it to this. If you equate a z value to a probability, how is that possible? You use z value to find probability, you use probability to find z value, but you cannot equate the z value to the table. Again, take care of the accuracy. So this thing is done. So this question is also removed. The numbers are decreasing. Let me choose one other normal so that we are done with normal. Now, this is the times taken in a minute to complete a particular task by an employee at a large company, mean, standard deviation. This thing over here, standard deviation, the square in the bracket, we write variance. Find the probability randomly chosen employee takes more than 28.6 minutes to complete the task. Greater than 28.6, standardized z value, z is greater than a negative value. So this is negative, z greater than a negative value is z lesser than a positive value. Direct reading, 6462 is what you get. Final answer, 646. 20% of the employees take longer than t minutes to complete the task, just like the question that we did. That is x greater than t is 20%. It should be at least 50%. Flip the inequality, subtract the probability from 1. Standardize. Table 80% is giving you 0.842, lesser sign positive, and then you get the answer. Now, the reason why I chose this particular question, yes, it's very like the previous two, but I'm focusing on this one. So this is the favorite question, and let me write down the year. This is October, November 2021. So this is October, November 2021. And the variant is 52. The variant is 52. And this question number, you can see from here, that is question number 6. So this is 6C. Now, this is important. Find the probability that the time taken to complete a task by a randomly chosen employee differs from the mean by less than 15.0 minutes. Now, we just did a question like this. That differs by 4 minutes. This differs by 15 minutes. 32.5 plus 15, 32.2. This is, I think, 0.2. I think it's just a misprint, 32.2. Okay, things happen. So this is 32.2 plus 50. Either you can work out with exact numbers, or if this is mu plus 15, this is mu minus 15. So you can still work out without the value of mu. Why? Because the mu cancels out. That is what I was focusing on, because there are questions in which it says x follows a normal distribution mu comma sigma squared. Find the probability x lies within two standard deviations of the mean. That is mu plus 2 sigma and mu minus 2 sigma. So that's how these questions are done. So this is also removed and this is also removed. Okay, that's good enough. And let's go to something like probability. So now this probability thing is there. There are 400 students at a school in a certain country. Each student was asked whether they preferred swimming, cycling, running, and are given in the following table. A student is chosen at random. Now, this is the game. That is, if a student is chosen, then the denominator is 400. Find the probability that the student prefers swimming. So swimming is 104 plus 31. That is 135 over 400. No need to reduce it. If you want to, you can. But as such, since the examiner has not specified, this is good enough. Determine whether the events the student is male and the student prefers swimming are independent, justifying your answer. The probability that the student is male, 31 plus 57 plus 92, 31, 57, 92 over 400. Probability student prefers swimming, that's right over here, 27 over 80. And what about the common thing? Is there any student? So let me just focus on the male and let me focus on swimming. So what is the common number? The common number is this one, which is 31. So now, is there any student who is a male and works out with swimming? So yes, the answer is 31 over 100. That's right over here. Now we apply this equation for independence. If probability of M intersection S is equals to probability of M into probability of S, we will say it's independent, otherwise it's not independent. And remember, and is denoted by intersection or is denoted by union. So that was a simple question. And this is, yes, the next one. That's also part of it. So let me just remove this thing. On average, all the schools in this country, on average at all the schools, 30% do not like any sport. 10 of the students from this country are chosen. Find the probability at least 3, greater than or equal to 3, do not like any sports. So 30% is your success. 10 is the number of trial, just a basic question. Too many terms to calculate. Choose the easy option. 1 minus probability x is less than or equal to 2. Make sure that these powers add up to the number of trials. It's a good idea if you have time to write these separately, or even if you show this much of working, I think that's good enough. But it's better to be safe than sorry. Write down these 3 also. Final answer, 3SF. Now a question about normal approximation to binomial. 90 students from this country are now chosen at random. Use an approximation. Find the probability. Fewer than 32 do not like any sports. The data is of binomial. This is N, this is P, this is Q. NP is mean. NPQ is variance. Why do we calculate NQ? Because we should always justify whether the examiner has asked for it or not. NP is greater than 5. NQ is greater than 5. Take 27, take 18.9, write it over here. Probability x less than 32. Binomial to normal, we always do continuity correction. So we have this value 32. We have the boundaries 31.5, 32.5. We are going in the left direction. So which is the right value? Since 32 is not inclusive, therefore choose 31.5. If 32 was inclusive, we would choose a line that would go on top of 32 and including it. As simple as this. Standardize, Z table, get the value, final answer 3SF, just take care of the accuracy. So now this thing is done, and let me choose this one. Okay, which one is this? Coding. So coding is important. A summary of 40 values of x gave the following information. Sigma x minus k is 520. Sigma x minus k whole square is 9640. Keep in mind, coding, I think in 2023, maybe there was one question, but very few questions. Mostly it was stem plot and box plot and histogram and CF curve, the boring stuff. This is the interesting one. Now, whatever is written inside the bracket, let it equal to y. Coding means assumed mean. We have made a substitution to make the data simpler. Given that the mean of these 40 values of x is 34, So the mean of x is 34. What is the mean of y? Just hold for a second. First of all, this thing, write it as sigma y. This thing, write it as sigma y square. N is 40. Y bar is coming out to be 30. Y is x minus k. In other words, y bar is x bar minus k. The mean is changed by addition, subtraction. The standard deviation remains unchanged. So y bar is 13, x bar is 34. Therefore, k comes out to be 21. That means from whatever the original data was, 21 was subtracted and the data of y was formed. Similarly, find the variance of these 40 values of x. Variance of y and variance of x is exactly the same. Standard deviation y square, that is variance. That is sigma y square over n minus y bar square, and then you get the answer. Now, let me add one other part over here. Sometimes they asked find sigma x square. So what we will do is that we will say standard deviation of x whole square is sigma x square over n minus x bar square. Now, this thing is the same. 72 square, I think this is stx whole square. They are asking for the variance. So this is not 72 square. This is just 72. Sigma x square is what we are looking for. And n is 40. And what is x bar? X bar is right over here. That is 34. So this is 34. So therefore, 72 plus 34. And this is x bar square. So this is 34 square multiplying with 40. That is sigma x square. Hence, we find the value of sigma. So I added an additional part for you people. So now this thing is gone. Now let's look at this thing. What is it? This is a permutation combination, a coding question, a question related to numbers. So I think there are 2 pages to it. Yes. So I've marked both the pages. Now the question says a security code consists of 2 letters followed by 4-digit number. The letters are chosen from A, B, C, D, E. So 5 choices for the letters. We are choosing 2. And the digits are 1, 2, 3, 4, 5, 6, 7. Out of 7, we are choosing 4. No letter or digit may appear more than once. An example is this. How many different codes can be formed? 2 out of 5 for the letters. 4 out of 7 for the digits. Simply multiply. Find the number of different codes that includes the letter A or the digit 5 or both. The easiest method is the subtraction method. Choose a possibility which does not include A, which does not include 5. That means out of 5 letters, we are left with 4 because A is gone. So we are left with B, C, D, E. And out of 7 alphabets, 1, 2, 3, 4, 5, 6, and 7, 5 is gone. How many are left? 6. We are still choosing 4. So this is the answer without A, without 5. And the answer of part A is without subtraction, without restriction. Just do the subtraction, you get the answer. Now this part. A security code is formed at random. Find the probability. Find the probability. The code is DE followed by a number between 4,500 and 5,000. So 4,500 and 5,000, the number could be starting with 45, 46, 47. There is no 48. There is no 49. So that means we want 45, 46, 47, and E is there. So I mean, that is just fixed. That's one possibility, one possibility. 45, one possibility, one possibility. So basically, we just have to focus on the last 2 digits. So any one of the remaining 5 will fill in the space. Any one of the remaining 4 will fill in the space. It's your choice to write 5 and 4. It's your choice to write 5p2. So that's 20, 20, 20. That is 60. And we are looking for the probability. So what's the denominator? The answer of part A. And this is the answer. So now this question is also done. Let me look at this one. Now, a good question. It says in a certain region, the probability that on any given day in October is wet is 0.16 independently of the other days. Find the probability in a 10-day period. Number of trials is given. That means it's binomial. Fewer than 3 days will be wet. So this is success. Less than 3, less than or equal to 2, and you get this answer. The next one. Find the probability that the first wet day is October 8th. So now no number of trials, probability of success is given. So that means the first 7 days are dry. The 8th one is wet. So 0.84 raised to power of 7. The last day is wet. Now it says for 4 randomly chosen years. So October appears once as a month in a whole year. For 4 randomly chosen years, the probability that in exactly one of these years, the first wet day in October is 8th October. So now that's a good question. This answer, that becomes your probability of success. And make sure that this is not the final 3 SF1. We should work in 4 SF. And P is this much. W follows a binomial distribution 4 comma this, exactly 1, 4C1, success raised to power of 1, failure raised to power of 3. So now, again, after a long time, I expect something like this. That means a probability is given, maybe from normal, maybe from geometric, maybe from binomial itself, and then another binomial is created. So I think this question is done. Now we are left with what? So let me choose this one. And before that, let me choose this one. Now it says box A contains 6 red and 4 blue balls. Box B contains X red and 9 blue balls. 6 plus 4, 10. X plus 9, X plus 9. A ball is chosen from box A, placed in box B. That means the probability will be out of 10. But over here, it's X plus 9. So since one more will be chosen, this will become X plus 9 plus 1, which is X plus 10. Now it says complete the tree diagram, give the remaining 4 probabilities. So 10 is replaced with X plus 10. That is the first thing. Red becomes red. So that means red was X. So now one more red is added. Blue and then blue. So blue over here is 9. One more blue is added. This X is the same as before. This is unchanged. Over here, this 9 is unchanged because a red was transferred. This red is unchanged because the blue was transferred. As simple as this. Show that the probability that both balls chosen are blue is this much. So both blue, that is 4 over 10 into 10 over X plus 10. 4 over 10, 10 over X plus 10, simplify, you get this answer. It is given that the probability that both balls chosen are blue is 1 over 6. So this answer equated to 1 over 6. We find the value of X. Find the probability that the ball chosen from box A is red, given that the ball chosen from box B is red. So first of all, we are interested in given. Given means conditional probability. Ball chosen from box B is red. That means it could be red, red, or it could be blue, red. The ending should be red. So 6 over 10 into this thing, 4 over 10 into this thing. And after substituting the values, this is the condition, and red, red goes up. And that is the answer. This time they have asked in 3 significant figures. So it's a must that you convert it. So now this thing is done. And yes, this thing is done. Okay, so now what is left? This one, a very nice question. So now it says 3 coins ABC are each thrown once. Coin A and B are each biased so that the probability of obtaining a head is 2/3. Let me make a small table on the side so that it's easier to look at the table rather than read and look for it. So AB, head is 2/3, 2/3. Therefore, tail is 1/3, 1/3. For coin C, that's also biased, but the probability of obtaining a head is 4/5. This is 4/5. This is 1/5. Let me just check one thing, the recording thing. That is all good, all going okay. So now over here, so therefore it says show that the probability of obtaining exactly 2 heads, 1 tail is 4 over 9. Let me read further. The random variable X is the number of heads obtained when 3 coins are thrown. So it's about throwing all 3 coins. And the first part is also about throwing all 3 coins. That is why it's asking for head and tail. Draw up the probability distribution table for X. So basically, I want this thing, and the examiner is doing me a favor of showing this part. So I can do the whole thing in one shot and then tell the examiner that the part that you have asked for is right over here. So now, first of all, look at the working that I've done. The head is in purple, tail is in orange. Head, 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 and then 4 orange tails. The combinations are 0, 3, 1, 2, 2, 1, 3, 0. The easiest one is the first one. 0 head mean all 3 tails. So take this, take this, take this, and multiply. The next easiest one, or it's a matter of convenience, that is all 3 heads. So that is 2/3, 2/3, 4/5. 2/3, 2/3, 4/5. Now, what am I doing? I'm just taking the probabilities and I'm multiplying the denominators. 3 into 3, 9. 9 into 5, 45. And then I can simply multiply the numerators. Now they're asking for 2 heads and 1 tail. So 2 heads, 1 tail. What are the possibility? Head, head, tail. That's the first one. And then head, head, and tail. That is the second one. And then head, head, and this tail. That is the third one. And you write it. This one can also be calculated this way, but why waste time? Why waste energy? Since it's a DRV, add these 3, subtract from 1, you find this probability. And then it's the same basic question, find expectation of X, find variance of X. So this thing is also done. Now, what are we left with? Another probability question related to the event kind of scenario. 2 ordinary fair dice, 1 red, other blue, are thrown. Event A, the score on the red die is divisible by 3. So it's only the red die. How many numbers are there? 1, 2, 3, 4, 5, 6. Out of these these 6 numbers, by bad, 2 of them are divisible by 3. 3 and 6. So the answer is 2 over 6, 1 over 3. Event B, the sum of the 2 scores is at least 9. So your choice whether to make a sample space diagram. I preferred to draw, write them as coordinates. The reason is, I'll just tell you what's the reason. So let me start with 3, because 1 adding with 1, 2, 3, 4, 5, 6 won't give me 9. The same with 2. The same with 3, except for 3, 6. So 3 plus 6 is 9. And then 4, 4 is 8, 4, 5, 4, 6. Then 5, 4, 5, 5, 5, 6. Then 6, 3, 6, 4, 6, 5, 6, 6. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of 36. Because 6 into 6, that is 36 possibilities. Now, how do I find the common one? A intersection means that is both A and B. So now the common ones is, that is why I have written it. This is for red die and this is for blue die. Red, blue, red, blue, red, blue. I have written it all along. So now how many of them has the number 3 from red or the number 6 from red? So that's 1, that's 2, that's 3, that's 4, that's 5. So that's 5 of them. So 5 of them is there. That is the intersection. So that is the answer for 2 marks, but this whole working has to be done. Hence, determine whether or not the events are independent. Let me just write one more thing, because mutually exclusive hasn't been asked for a long time. Probability A intersection B is 0. This is for mutually exclusive events. For independent, the working is right over here. That is probability A intersections B. That should equal to probability of A into probability of B. And yes, there is also another formula which is used very rarely. That is probability of A or B. That is probability of A plus probability of B minus probability of A intersection B. I hope you remember a question that was about kids are cops, something like that. That knowledge was used over there. So now the working is pretty simple. This is 5 over 36. These are the 2 individual probabilities multiplying together. Since they are not equal, therefore they are not independent. So now this thing is done. And now we are on the last 2 questions. That is about permutation combination and one common confusion that is caused by something. Let me explain that. Now the question is, find the number of different possible arrangements of the 9 letters of the word celestial. C-E-L-E-S-T-I-A-L. So make sure to write it like this. There are 2 E's, 2 L's, and then 5 different ones. Without any restriction, arrangements 9 factorial divided by 2 factorial for the E's, 2 factorial for the L's. Find the number of different arrangements of 9 letters of the word celestial, in which the first is C, fixed. 5th is T. So first, this is T2, this is T3, this is T4, this is T5, that's fixed. And then 7, 8, 9, and the last letter is E. So actually, this E is right over here, my bad. So that's a very big eraser. So therefore, this 9th one is right over here. Okay. And it says, in which, let me just double check. So this is 1, 2, 3, 4, 5, 6, 7. Aha, this is the 9th one. So I think that original thing was all good. Okay. So now the thing is, last letter is fixed, that is the T9 position. How many spaces are there? 6 spaces. How many letters are there? 6. So 6 factorial divided by 2 factorial, because the 2 L's are still in motion. This E is fixed. This T and S is fixed. Find the probability. People forget the word probability. That the randomly chosen arrangement of 9 letters in the word does not have the 2 E's together. There is the method of together and then the subtraction. I prefer the other method, the space method. So we have 2 L's. We have CSTIA. How many spaces are there? 8. Out of these 8 spaces, we will fit in 2. And 1, 2, 3, 4, 5, 6, 7. That is 7 factorial divided by 2 factorial for the L's. That is the answer. The answer for the first part is 90720. The answer for this one is 70560. Just take the probability. I'm leaving the answer in fractions. Now, this is the most important one. Whenever we are talking about identical alphabets and we are talking about selection, so when we use the word selection, NCR won't work for identical objects. What do I mean by that? Let's say I have 2 L's, 2 E's, and CSTIA. If I'm choosing 1 L, if I'm choosing 0 L, I won't write 2C0. I won't. I'll simply ignore it. If I'm choosing 1 E, I'll just choose 1 E and I'll discard the rest. I have given the example of a photocopy paper, a Xerox paper. Just choose one, discard the rest. So you won't write 2C1. Why? Because we are talking about number of selection. And then in this particular question, they are saying if the 5 letters include at least 1 E. At least means greater than or equal to 1. So it could be 1 E, it could be 2 E. At most 1 L. That means lesser than or equal to 1. That means it could be 1 L, 0 L. So write it in a very organized manner. 0, 1, that's one possibility. 0, 1, and then 0, 2. 0, 1, 0, 2. And then 1, 1, 1, 2. 1, 1, 1, 2. Choose 0, choose 1, all good. Nothing to write. No NCR. Choose the 4 from the remaining 5. 5C4. Choose 0, choose 2. Choose the remaining 3 from the remaining 5. From these 5. Choose 1, choose 1. Discard the extras. 5C3. Choose 1, choose 2. These 2 to be chosen from 5. Add it all up. Now the exact opposite is this thing. This is from a very recent past paper. I think it's 2023 or something like that. So now it says, and there was also one in 2021 on which I've made a video by the name Tomorrow. 4 letters are selected at random from 9 letters of the word Andromeda. So there are 2 A's, 2 D's, NROME. Find the probability that this selection contains at least 1 D, exactly 1 A. So now when they're asking for probability, it's just like that I have $100 bills in my pocket. And yes, they all are identical, but the choice is out of 3. So over here, I'll write NCR works normally. Why? Because we are talking about the word probability. So this is probability, this is selection. That is the difference. So now over here, I need at least 1D. That is exactly 1D, exactly 2D. And exactly 1A, exactly 1A, exactly 1A. So now I'm writing, I'm selecting 1 out of 2, 2C1. I'm selecting 1 out of 2, 2C1. The remaining 2, because I need a total of 4, the remaining 2 from these 5, that is 5C2. So 2C1, 2C1, 5C2, that is 40. Now I'm choosing 1 out of 2, 2C1. 2 out of 2, that is 2C2. 1 out of 2, because I need a total of 4, that is this. Now this is coming out to be 50 without any restriction. 9C4 is 126. Probability is 50 over 126. So that's all about it from my side. Just work clearly, show all your working, and don't panic. Any question that seems difficult, come back to it at the end. Wish you the best of luck.